Hi everyone, welcome back to our channel. Today we are going to find the condition for reciprocity and symmetry in jet parameters, where this is also called impedance parameter. So what is the meaning of reciprocity means? We have to find out the ratio of response to the excitation. Response means current divided by voltage. So we will find the output current to the input voltage, and again what we'll do is we will find input current to the output voltage excitation. So this is nothing but output current to the input voltage, okay, or input current to the output voltage. So when you reciprocal the voltage source at input side and output side, the ratio of admittance upward remains same. And the case of symmetry also, we will short circuit and we'll open circuit in the terminal and we'll find out the impedance. Let's try to see how to get. So before solving itself, I will make you the things very clear. The Z parameters can be represented as Z11, Z12, Z21 and Z22. So what is the condition for symmetry we have to get is, so the diagonal. So this is the condition for symmetry. Z11 is equal to Z22 is the condition for symmetry actually to what we require. Okay, and the condition for reciprocity is, so we want to get the condition for reciprocity is Z12 is equal to Z21. So first we'll solve the condition for reciprocity. So how to solve? Let us try to view here. Okay. So before solving, let us try to write down the fundamental equations of Z parameter. So what are the fundamental equations of Z parameter is? So V1, V2 are the dependent variables, that is equal to Z11, Z12, Z21 as well as Z22 is the Z parameter into I1, I2. So here when you write down the equation of V1 is equal to Z11 I1 plus Z12 I2. Second equation is V2 is equal to Z21 I1 plus Z22 I2 is the next equation. So here what we are going to do here is, so now we are taking our Z parameter network and this is the applied V1 and the current will flow into the network. This is a default representation. So at output what we are going to do is, so previously the current was flowing into the network as I2. So now we are changing the current is flowing outside of the network. Since it is going like this is positive. When it flows in opposite, this is nothing but I2. And how the current will flow? Whenever it is open, it doesn't flow. Current only will flow whenever it is short circuited. The condition what we want to substitute is short circuiting the output port and current terminal has to be reversed. And we want to find out, so what we need to find out is we have to find out the admittance value. What is the admittance value is response means output to the excitation. What is the response here? Current. So current is nothing but what? I2 divided by excitation. What is the excitation? Voltage V1 are applying. So input port we are applying the voltage and we are measuring the output current. So output current, this current is called response and this is called excitation. Output current to the input voltage, we have to find this ratio. So now in these equations we are going to substitute these two parameters. So we want to make these two modification. Okay, so V1 is equal to Z11 I1. Okay, and I2 is how much? Positive. Here we have to make negative, which is minus Z12 I2. And in this equation the same we want to make V2 is equal to 0 here and this is Z21 I1, and I2 value is minus. I2 is minus means minus Z22 I2. So see here, we want an select an equation which consists of I2 and V1. So this equation has I2 as well as V1, but the disturbing element is I1. So now we want to express I1 either in terms of I2 or V1. So now check this equation. It is having all our required answers. So this can be written as Z21 I1 is equal to Z22 I2. How to write down I1? So I1 I can write down it as Z22 divided by Z21 I2. We can write down. So now substitute this expression. You see here, this I1 is in terms of I2. The problem is solved. So we can write down V1 is equal to Z11. What is the value of I1 here? So this is Z22 divided by Z21 into I2 minus Z12 I2. So here we should have only I2 and V1. Okay, here we have I2 and V1. So let us take I2 as common. Therefore, the resultant is Z11 Z22 divided by Z21 minus Z12. When you take I2 as a common term. So we require the ratio of I2 by V1. So what I'm going to do here is I'm going to take the LCM. Z21 is the LCM term. This is Z11, Z22 minus Z12 and Z21 into we require the ratio of I2 by V1. So automatically bring this I1 to the denominator. Therefore, I2 by V1. So this will come to the numerator, which is Z21 divided by Z11, Z22 minus Z21 as well as Z21. This is response to the excitation by performing the modification what we have been discussed. Similarly, we have to do the next modification here also, and we also want to find out the response to the excitation. One second. So how to find out is, so consider the same two-port network, and now we will give the current at output side, which make a current to flow as I2 by applying a voltage of V2, and we will take the input, and previously the current was flowing like this, that's why we have taken plus I1. Now the current is flowing in, will flow in opposite direction, minus. How current will flow? The condition here is V1 is equal to 0. So we have to substitute V1 is equal to 0 and I1 is minus 1. So substitute V1 is equal to 0 as well as I1 instead of minus I1. Okay. So by substituting these two in this fundamental equation, and what we need to find out is response. What is the response here? I1 divided by excitation. What we are exciting? I1 by V2 ratio. This is called response to the excitation ratio. So the procedure of learning is just watch the video very carefully and write down the, then you take a white paper and you try to do the same procedure. Then you will get the confidence what and how we are doing. So we want to find out I2 by V1. So these equations will be modified like this. Okay. So now see here. So V1 is 0. So 0 is equal to I1 you have to write down minus. This is minus Z11 I1 plus Z12 I2. One equation is completed. Second equation is V2 is same. V2 is equal to I1 is there. We have to write down minus Z21 I1. Okay, and plus Z22 I2. So see that you substitute V1 equal to 0 and I1 is equal to minus 1. V1, V2 will be there, I1 is minus I1. And now you see here, check out the two equations where we have I1 by V2. So this is I1 by V2. But disturbance creating term is I2. Now we want to express I2 either in terms of I1 or V2. Check out this equation. So in this equation we can do here. So here you can write down Z11 I1 is equal to Z12 I2. So now I want the substitution for I2. So I2 is equal to Z11 divided by Z12 into I1. This is what the substitution we actually require. Now use this in this expression. Therefore, and we need to find out I1 by V2. So the resultant is V2 is equal to minus Z21 I1 plus Z22 I2. What is the value of I2? We are going to get is Z11 divided by Z12 into I1. Okay, so Z11 Z12 into I1 is the resultant value. So now check out, we require I1 by V2. Now let's try to take I1 as a common term. Okay, so V2 is equal to, when you take I1 as common, this is Z minus Z21 plus Z22 Z11 divided by Z12. So now let's take LCM. V2 is equal to I1 of, so the LCM term is Z12, and here you are going to get minus Z12 and Z21 plus Z11 as well as Z22. So here we require the ratio of I1 by V2. So now bring this I2 to the denominator. So I1 by V2 is equal to, the resultant is Z12 divided by Z11 Z22 minus Z12 and Z21. So this is the resultant equation we are going to have. Okay, so now compare these two equations. These are nothing but response to the excitation. When you compare the first equation with second equation, we can see here the denominator terms will get cancelled out. So automatically Z21 is equal to Z12 will be the condition for reciprocity. I mean, reciprocity means reciprocaling of input voltage we are applying, output current we are taking. I mean, we are changing, we are giving input V1 and we are finding current I2. And we are changing the port, and we are applying the voltage at second port, and we are finding the current at input port. This is called like changing the, or reciprocaling the position of voltage sources is called reciprocaling of positions of voltage source and currents. But this is the condition for reciprocity. Now, hope you got the first condition as already I discussed. What is the condition for reciprocity is Z12 equal to Z12. We have been successfully obtained. So you can see here the diagonal elements are Z12 equal to Z21. So you have a lot of derivations of 3. We'll proceed in the next video. Now we want to prove the condition for symmetry. So what is the condition for symmetry? Already we have the formulas here. So these are the basic formulas we have. So Now the conditions means we want Z11 as well as we require Z22. So this is Z11 I1, Z12 I2, Z21 I1, Z22 I2. So here I want this Z11. So this term should not be there. So what I'm going to make is here output port is open circuited. Output port is open circuited. The meaning is I2 is 0 now. You substitute I2 is equal to 0 in this expression, automatically V1 input voltage to the input current is Z11. Here I require Z22 value. How I can get how I can get Z22 is by making this term as 0. How I can make this I1 as 0? You just see that input port is open circuited. Whenever it is open circuited, current I1 becomes 0. So the meaning here is, so you have an two-port network with V1, I1, and output we are going to make it as open. I2 is 0. Second step, what we are doing is, we are applying the voltage and this end, and the input port we are going to make as open, which is I1 is equal to 0. That's what we are doing here. By substituting I1 is equal to 0, automatically we will get V2 by I2 is equal to Z22. When you compare this equation with this equation, so input voltage to the input current is impedance, output voltage to the output current is called impedance. When you compare both, the condition for symmetry is Z11 is equal to Z22. So hope you understood the condition for symmetry in an Z parameter model is Z11 is equal to Z22. The condition for reciprocity is Z12 equal to Z22. So here all the time when you are finding the reciprocity, you have to find out response to the excitation. So I am revising the class. So I am finding response to the excitation. I am finding I2 by V1 ratio, and similarly I am finding I1 by V2 ratio, and I am comparing and I am proving the condition for reciprocity. I will do the same for y parameters also. Okay, so compare it, and now the resultant answer is, what is the condition for reciprocity is the diagonal elements are the condition for symmetry, which is Z11 is equal to Z22. What is the condition for reciprocity is half diagonal elements. Half diagonal element means Z12 equal to Z21. So anyhow, here we have to find out admittance. We have to compare admittance, and here you have to compare impedances. That's called response to the excitation. So this is what the procedure. Just observe how I am doing and try to practice of your own, and you will be very perfect in the exam. So if you're watching for the content for the first time, please like the video, please share with your friends, and if you have any doubts, let me know in the comment section, and kindly subscribe to the channel. This is a free channel for the benefit of students and faculty. We'll meet in the next video. Thank you for watching. US Ram.